Dear student, good to have all of you with me. The second part of histology of digestive system. In this lecture, we will focus about small intestine, large intestine, liver, gallbladder, and pancreas. All right. Small intestine is like when we finish the chemical digestion of food, and it is responsible for absorbing most of the nutrients. The whole process is take at least 12 hours, and the wall or the, the structure of the small intestine is like coiled with a thin wall, and the length is approximately 20 feet. It extends or starts from pylorus of the stomach to the cecum of the large intestine. Let me give you information about this sentence. The pylorus is that the first part of the furthest, not first as the start, not this part of the stomach, and connect to the duodenum of the small intestine. And it is we have divided into two parts, either interium that connect to the body of the stomach, and the second one to the pyloric canal duodenum. The main function for this site, it's like a gateway or it's like door between the stomach and the small intestine, which allow to the food to whole content of food to allow or pass from stomach to the small intestine, and it is prevent that the partial digestive food and digestive juice to pack or to return to stomach. In general, small intestine classified into three segments. It is duodenum, jejunum, and ileum. So here I have a cartoon diagram just to show where is the cecum. It is in the first part of the ascending colon. Is the first part of the large intestine, and we have transfer, and then we have descending, and you will see that the of the stomach, and then when it started the point of pylorus. Right. Then histologically, all the digestive system tract have four main layers. I will start from innermost layer to the outer. So from innermost layer, it is a mucosa. It's contained of epithelium, lamina propria, and muscularized mucosa. While submucosa is like contain connective tissue layer, and it is keep in your mind. If it is connective tissue, that means have blood vessels, lymphatics, and also submucosa plexus. So let me give you a clear explanation. What does that mean, a plexus? Plexus is like lines on the wall of the submucosa, and the main function it is configuration of luminal surface, control glandular secretion, water transport, alert for electrolyte, and also regulate the blood passage for this area. So plexus is found between um, between the layers on the walls. Okay, now we have the third layer. It is a muscularized external. It consists of a smooth muscle layer, and outer is longitudinal layer, while the inner is like a circular layer, and this mesenteric plexus lies between them. All right, we have two places for the plexus, one in submucosa and the second in muscularized external. Then we have the outer layer, serosa or adventitia. It's comprised that loosely arranged fibroblast and collagen, and also we have um, uh, blood vessels, we have nerves cover this area. The majority of the small intestine, adventitia or serosa, is covered by mesothelium, and it is commonly called serosa, as I said. But because um, because small intestine have the number of modification. This number of modifications help to doing the function. The main function, as I said, for small intestine is the absorption. So we need a large number of folders. Let me explain what mean folders. Folders, for example, if you have t-shirt and you start to tie it and fold it one side by side, then you have large folders or plique, and then that you have um, um, a large surface, and like what we have for modification in a small intestine. Why we need large space? It's like a proportional relationship. Um, if you have large space, then you have an increased absorption rate. All right. That what does that mean? If we what we need the large numbers of holes. Okay, I converted all the speak in the previous slide into the table and then to cartoon diagram. Here we have for the mucosa, you see epithelium, lamina propria, and muscularized mucosa. Look to this area. Submucosa and muscularized propria, you see plexus. It's like lines between the walls. And half the for muscularized is like circular and longitudinal muscle and vice versa. While the in cartoon diagram you will see we have in submucosal and mesenteric you see plexus, and then as, as we see here in the transfer section of um, the wall of intestine. All right, small intestine, as I said, because we have several modifications, so we need to um, have more details about these modifications. First, we have Placia circularis. It's like large number of mucosal folded, and it is arranged circularly around the lumen. Villi, it is another structure which help to extend the intestinal lumina. As I said, we want to extend, we want a large space on surface of a small intestine because we need high rate of absorption. And then we have microvilli. It's absorptive surface of the villi, and it's increased by the microvilli. While crypts of lubricant, there is invaginations of intestinal mucosa between the bases of the and form the intestinal glands. Crypts of lubricant, let me clear this point, is like a tubular gland, or it's called intestinal gland, and it is lie between the villi. Villi is like shape of fingers. And lubricant, I think it is German anatomist. What we see here in cartoon diagram, you see A, it's a small intestine, the normal layer. We have blood vessels, sperm, and the whole small intestine. We have lumen, we have circular folds, which is a plaque here. Look, look to the surface and back to our example when I told or when I said we have t-shirt and we start to fold it or tie it one layer, one by layer. Look to the plaque here circulate like this folded. Then if we take one or piece part from the leg, a magnification, you will see it's like absorptive cells. You see like fingers, and it is spiral in shape, and you will see the intestinal crypt. And then that, now we take another part, you will see microvilli, it's like a brush holder, and give the space to increase the absorption. All right. So now we go to the segment. So part of the small intestinal, we will start by duodenum. It is epithelium of a duodenal mucosa, is regular, simple columnar, and microvilli of these cells form continuous brush border. We see brush border, what that means. And the villi of this region is short, uniformly in size, while the intestinal crypt is extended downward to high. Um, very deep level of the tunica mucosa, and there are simple citrate tubular glands. And that gland is surrounded by cells. The cells here we have enterocytes, goblet cells, stem cells, bunny cells, and endocrine cells. So we go to have a little information about each cell. All right. Enterocytes, um, these are observed epithelial cells. A goblet cells is like a glass-shaped unicellular gland, and it is secreted mucus supporting the enterocytes. It's a protective function, while endocrine cells is located in the region of the crypts and are lots in numbers. Also, there are similar to this in the stomach, but it's a different kind of enzyme or hormone. They don't secrete into lumen. They go to direct secretion into a blood passage into the capillaries and lamina propria. Also, we have a stem cells found in the lower third of the crypt, and they divided to replace enterocyte and the mucuses of the another segment is jejunum. Jejunum is longer and more irregular. Muscularized, it's separate or actually it's absent. There is no muscularized mucosa. There are also folds, as I said, plica circular, and we have a permanent structure help to increase the surface area and the snow glands in this part. Another structure, the same that found in duodenum. Ileum, ileum is different. It is large aggregation of lymphatic tissue of submucosa, and it is half lymphatic nodules or called Peyer's patches, and it is good site to development B lymphocyte, and it is, as I said, it is germinal centers to development for B lymphocyte. Um, the shape of fillet in ileum segment is like a leaf, and the other structures that are found in the duodenum. Okay. Large intestine is like in the length 1.5 meter, while in diameter is 6.5 centimeters. The main function is absorb most of water and electrolytes from the remaining food, or actually digested material, a watery material that first enters the large intestine and then that's solidified to become feces. So here we have converted from watery material then to solidified and the feces, and it's still in accumulation or storing in this part until the body ready to do desiccation process. Um, um, the absorb rate is a very small percentage of nutrients still remaining in the digested material. Large intestine, as I said, in the small intestine we have a 3 segment, but in large intestine we have 4 segments. We have cecum, colon, rectum, and anal canal. So let us start by appendix. Appendix is like evagination of the cecum. Let me give you information about evagination. Evagination, something is the start and uh, and increase to be bigger, and it's characteristic by the relatively small bladder and irregular lumen, is caused by presence and uh, abundant lymphoid follicles in the wall, and it is from circular layer of the mucosa, and many infiltrate the submucosa. Although in general, structure is similar to that of large intestine, which it is contain fewer and shorter intestine glands, and it is have tinea coil. What does that mean? Tinea coil, as I define, is like three longitudinal bands of muscle that form that's found in ascending, transfer, and descending of the large intestine or the colon. Right, colon. The second segment of large intestine is the lining epithelium. The mucosa of the large intestine does not have villi, and epithelium is lined by simple columnar absorptive secretory, and we have goblet cells in large number. While the lamina propria, it is contain mucosal glands, some solitary lymphatics nodules, and present in the lamina propria. Well, anal canal, we give very simple definition. It is the lower part of the large intestine, and the function is just to give um, um, passage for feces outside the body. All right, let's be back to the accessory for digestive system. We have liver. It's composed or consists of four type incompletely separated loops, and it is supported by ligaments. We have white and left loop, and we have falciform ligament, round ligament, caudate loop, and quadrate loop. The main function of liver is to produce bile, which is about like greenish fluid, and it is wanted when the body needs um, to break down and um, to break down into small droplets to help the chemical digestion. The second function it is detoxify. Um, um, example, a drug, metabolite, and poisons. Poisons, something like toxins. Also have storage function for excess nutrients and vitamins, and it is ready to give the body when it is needed. Synthesize the blood the plasma proteins such as albumin, globulin, and proteins, and also when required by the clotting, the process of the blood clotting. Phagocytosis is the immunity rule, and it's also a help to break down the help either break down or recycle for the age or damage or the die are not healthy erythrocytes and forming out as elements. Classified into two areas, either stroma or parenchyma. So for stroma is like capsule, torbicular, and reticular connective tissue. Liver is surrounded by thin connective tissue, okay? And the capsule is Gilson's capsules. You will see here it is covered partially by peritoneum. And then it goes to inside, from outside to inside. Then we have thickened as porta hepata and send trabecula into the liver, then divided the parenchyma into segment or loops. And reticular connective tissue is made of reticular fibers, reticular cells, and forms like a framework for the cell column of forming liver lobules. The second part is parenchyma. Here we have parenchyma. It's like form, the main formator of the liver, hepatocytes, blood vessels, and bile ducts. You will see here in cartoon diagram. We have in general we have for like a whole a liver lobule, and we have three liver lobules. Okay, it's either classical lobules or portal lobules and hepatic acids. Right? Classical liver lobule is like this concept of blood passage from the peripheral, here we have it from peripheral, and goes to into the central vein. So it's from peripheral, from outer to inside. And the bile manufactured by liver cell enters into the small intracellular space, which is called bile canaliculus, and it is located between the hepatocyte and the blood passage to the periphery of the lobule to the intralobular bile ducts of the portal areas. The second one is, as I said, portal lobules. It's all hepatocytes that deliver their bile to the particular as intralobular bile ducts. The third one, hepatic acids, institute like three poorly defined concentric region of hepatic parenchyma surrounding distributing all of them in the Again, we have another um, accessory digestive organs is gallbladder. It is concentrate the bile produced by the liver and stored into the concentrate in the starch body when it is needed during digestion. Cystic duct is connected to the gallbladder and to the common bile duct and can hold approximately between 40 to 60 milliliters of concentrated bile. With the main function or the primary function of the gallbladder, be careful, is collect, store, concentrate, and expel bile when it is needed for emulsification of fat. Bile is continually produced by liver hepatocyte and transported by excretory ducts to the gallbladder for storage. All right. It's not big difference about the histological, the layers of the as we said in the previous slide for small intestine. But here I would mention something about um, the axillary digestive system. The mucosa is simple columnar epithelium, and the lamina propria is loose connective tissue and diffuse lymphatic tissue, and also we have vein and arterioles. Where muscularized is the smooth muscle fibers, connective tissue layers. We have blood vessels, lymphatics, and nerve. The serosa cover the entire unattached gallbladder and surface, so it is surrounded. Then we have another type. It's pancreas. It's well actually it's mixed both endocrine and exocrine function. Um, Endocrine function are performed by pancreatic islets, while pancreatic islets, while the exocrine activity results in secretion of digestive enzymes selectively called pancreatic juice into the urine. So be careful, endocrine to the islets and the exocrine for pancreatic juice. Again, it consists of either exocrine portion that when secreted daily is about 1,200 ml of enzyme, which it is very required in digestive for dietary fats and carbohydrate and protein, while endocrine portions secrete hormones and it is very essential to control the metabolism of carbohydrates. In general, the biliary apparatus is like network of ducts and carry bile from the liver and gallbladder to duodenum. The left and the right lobe of liver carry bile into the left and right hepatic duct respectively, that means one by one. Also, so the left and right hepatic ducts, it's like married or a mix to form single hepatic duct, and the cystic ducts attached to the common hepatic duct and carries bile to and from gallbladder. So for this slide, my lecture for digestive system, the whole digestive system is finished. Would like to go back for each slide and give you what is important. I know digestive system, if it is part one and set and part two or second part is difficult, is not easy. But just focus about what I give you from this guide. For small intestine, you need to have an introduction. So the first slide is like introduction, and any cartoon diagram just to see it, not to and have a knowledge, not to draw at all. For histology, these four layers is the same for all of them. So it depends on this slide. This is just for knowledge. Um, um, this this is good to know and give define for each part. Be careful about duodenum and jejunum and ileum. Look, for duodenum, the first one, the epithelium of the duodenum is regular, simple, columnar, and microfillet of these cells from continuous branch border. So, when you go to jejunum, you will see the first layer between round bracts is like characters. If I said give characters for jejunum, it's good to tell me that it's longer and more irregular. While for ileum, you see the this round practice, you will see the ileum is large aggregation of lymphatic tissue in submucosa. This gives you an idea how to recognize duodenum, and ileum. So focus about these three sides. Let's talk about what I want. Yeah, for this one, the cells for surrounded the tubular glands. It's very important to know define for each one. Thyrocyte, pupil cell, endocrine cells, and stem cells, right? Because they are similar and they don't. It's not defined for cells. All right, then we continue through large intestine. We have this like introduction segment for large intestine, and then we have appendix, give introduction, colon also, and anal canal, liver, very important as affection, introduction, stroma, and parenchyma, just for knowledge. I don't want you to have this just to have knowledge. For let me explain again. Liver, I want this as a introduction faction of liver. Stroma as the first part, the second part parenchyma, just to knowledge, and then accessory digestive system for gallbladder. This is one is very important to give you all define about gallbladder. This is mucosa, muscularized, and serosa, just for knowledge. Pancreas is important as a define, and the final slide is important. So good luck and thank you.